Hello and welcome to another Microvellum live event. My name is Clay and we are glad that you are here with us today. We are streaming once again from our headquarters here in Southern Oregon on this 6th day of December 2017. In case this is the first time that you've joined us for one of these live events, we host these free educational sessions weekly for our users and for those who are just curious about our solution and how our solution may help them in their business. We're streaming here today on two platforms, here on the Zoom platform as well as our YouTube live stream. And you can ask a question at any time on either platform. Here in the Zoom platform, you can select that Q&A button there in the navigation panel to type your question, or use the comments area on YouTube or here as well in Zoom. And we are recording this event and it will be available within the next couple days on our website and Help Center. And make sure that if you haven't already to subscribe to us there on YouTube. That's how you can receive notifications on future live events. So if you've been waiting for the recording of last week's event where we showcased some of our drafting tools and we discussed best practices, you can now find that event posted. And I'll go ahead and put a link here in the comments section, and you can then watch that a little later today or have a link to bookmark it there. So that's a good event. If you missed it last week, you may want to brush up again on what was covered, and you might want to check that link out. So I'll go ahead and put that link there in the comment section. There you go. All right, so today we have lined up a demonstration with Adam Dierig from Advanced Dimensions, a company specializing in laser measurement tools. You can learn more about Adam and his team at their website at advanceddimension.com. And for the next hour or so, we actually have the chance to hear from him as we get into a review of the 3D Disto laser. I'd like to actually get a pulse from those watching today of how many people are actually using laser measurement tools currently. So I'll go ahead and display that. I'm going to launch that poll. All right, hopefully you guys can take that and let us know, those who are watching, what you're using, or not what you're using, but if you're using the tools, laser measurement tools already. So today we're not only going to fully understand how this tool works, but we're also going to examine how you can use it alongside your Microvellum software. We're going to have a look at the Leica software that comes with the laser, and we'll show you how to collect those field dimensions and how you can import these exact measurements for creating walls and countertops, soffits, die walls, and so on. So Adam, thanks for joining us today.
Well, thanks for having me.
How's it going up there in New York?
It's going. It's still getting colder by the day, so.
Yep. Winter is coming.
Yes.
All right, so I think I can speak for most here today when I say that we are excited to learn more about these laser tools. But before we get into what you've prepared for us today, maybe we can pause just for a little bit to help our audience understand a little bit more about you and your background and Advanced Dimension. So
Sure.
How did you get started in the woodworking industry?
Well, basically, ever since I was a young teen, I was interested in woodworking, and I actually went to school for woodworking college. And then when I graduated, I started at a local cabinet shop as just a cabinet maker, and I worked my way, into the CNC world and into the drafting world from there because of I have a love for woodworking, but I also have a love for mathematics, and AutoCAD kind of hit home with the mathematics side of things, and it all kind of came together. And now I'm doing it full time and still loving it.
Awesome. So with a background as a Microvellum user and a love for drafting, you also have a few other services that you have, don't you?
Yeah. So my business, we sell the laser measurement tools as one business, and then we also do drafting and design work for the millwork industry, and we're branching out, constantly. But it's one of those things that we keep very busy doing everything.
Yeah. So how many people now do you have on your team? I know you're growing recently, but how many are you at now on your team?
I think we're at 14 right now, and growing. We're in need to hire a couple more people even now because of our demand. And
you're using Microvellum. So for those people who are watching this that are Microvellum users, you are still using Microvellum to help you with that drafting, so you can take projects and work with our users at that level as well, right?
Yep, we just started using Microvellum this year, even though I've been using it for a while. I'm
Hmm.
implementing it into my team, and we're able to help with that. And yeah,
Yeah, that's great. So you're a longtime user specializing in drafting, and you like to surround yourself with precision. I get it, and that's great. And I've seen this 3D Disto laser tool in action, and I must say that it's definitely impressive. And I personally can't wait to see what we have cooked up here for this demo. But before we do that, I just want to make an announcement for those of you in the audience. If you have a question for Adam, please let us know there in the question and answer area or in the comments, and we'll be monitoring those areas throughout this presentation today. And we'll even see if we can get Adam to answer some of those questions live for you. We have a lot of people on today from Poland to Australia, New Zealand, Canada, and here obviously in the US. So we'll do our best to get those questions answered. And if we don't get to your question, which we will certainly hope that that doesn't happen, we do get every one of these answered today, you can always follow up with us afterwards or even during the event to send us your comments, feedback on today's event at live@microvellum.com. All right, Adam, what do you say? Let's get into it.
sounds great.
All right.
I'm going to share my screen. Yes. And share it. And I'll just get into a little bit too about how I got into the laser measurement tools. Because I was a drafting design company, I purchased a handheld Leica, and I would go out into the field and I would verify the field conditions of the kitchen or whatever millwork project we were working on. And it evolved into quite a lot of people inquiring, hey, what's that tool that you're using? Or, hey, you know, that's a really interesting way that you're doing that. And I was selling the tools, not being a dealer, and then it evolved into me saying, hey, well, I might as well sell the tools, you know, use them, I love them, and to show that love to other people, you know, might as well be a dealer. So that's kind of how I got into it. And today I'm going to focus really on the 3D Disto. I'm going to touch on some of the other laser measurement tools that are out there and kind of what the difference is between the 3D Disto is and the other tools that are out there, just to kind of touch on that. But my screen now, you should see the 3D Disto, and this is kind of like the package that you get, but I use this just to kind of show what the tool looks like. I'm sure you've run into this tool in trade shows and in other areas, and basically what the tool does, and I'll expound on this as I go through, but what the tool does is it simply captures the X, Y, and Z coordinate points. It can calculate angle and it can calculate distance, and with those two items or two things, you can basically calculate all the coordinates. And the beauty of this tool that I found, as it compares to other ones, is the accuracy is by far the best. So the accuracy on this tool is 1 millimeter at 10 meters. So for all of the millwork that I ever do, the 1 millimeter is where I shoot for. You know, the 30, 1 millimeter is just a little bit less than a 32nd, or a little bit more than a 32nd, and that's what I go for when I'm out in the field using the tool. That's what our millwork requires during installation. And I found with this tool, I've never had an issue with somebody giving me bad feedback in terms of a bad fit or something like that wasn't that was related to the tool. So this is the 3D Disto, and then I'm going to just go into how it works and the software side of things, and then I'll show you, like on the Microvellum side of things, how that works. Before I get into the software, though, I'm going to just go over kind of the key differences between this laser measurement tool and some other like point clouds. The 3D Disto, if you've heard of it before, I think a lot of people use it for countertop templating and stuff like that. And yes, it works great for that, but it really excels in capturing really any three-dimensional measurement. So we've used it for wall paneling. We've used it for capturing helical staircases. And the thing that's nice about this tool is you can capture only the area that you need instead of capturing, millions of points. You're capturing maybe thousands of points or hundreds of points, but you're walking away with the information that is crucial, that you can then go back and edit it when you get back home. So I have just a couple of pictures here to just kind of show. So typically with the 3D Disto, when you go out and you measure, this was a room I measured a few weeks ago in a penthouse in New York, and we were doing wall paneling. So I was able to just capture, I think it was about 230 points on all the walls and the ceiling and the floor. And then when I brought this back into CAD, I'm able to tell, if the walls are out of plumb, if the floor is not level, if the ceiling's not level. And, really all that I needed was this. So when I walked away, I was able to bring this right into CAD and then start working from that. The other point cloud machines that are out there will give you a little bit more of a complex point cloud. So this is one that was taken. This was one that was taken with one that does like millions of points, and there was 2 setups here. And this is great. It gives you a really good picture of what's going on in this room. There's quite a lot of tools in there and a lot of different areas. But when you go back, it's great for capturing, but when you go back to start editing, I find it's very difficult and cumbersome to like figure out, how to measure things and, get just what you want. Where with the 3D Disto, you can pinpoint exactly what you want, and you're only, there's no mess, there's no extra. So that's just kind of a difference between the 2 units, or the 2 different styles. Each does a point cloud, but one's just a little bit more pinpointed. The other thing that's majorly different is the accuracy of the unit. The 3D Disto is a millimeter at 10 meters, so about 30 feet. And pretty much all the point clouds on the market, when you combine distance and angle, are in the 6 millimeter to 8 millimeter accuracy range. So I found, in my line of work when I'm going out in field dimensioning, that range is just a little bit over what I need. And that's why I favor the 3D Disto. All right, so that's enough of that. Now I'm going to show you, so when I use the 3D Disto, you got to go out in the field and you got to capture the data. So what I use is the Leica software, and I have just a PDF here to kind of show you where we're looking. So on the left is a PDF of my office. This just to kind of give you an idea. And then on the right is the software. And what we're doing right now is we're viewing through the lens of the 3D Disto. So I'll bring the picture back into view. So right here, this is the lens, the camera, if you will. And then the 3D Disto, turns 360 degrees around the horizontal, and it turns, 200 and so around the vertical. And so when we use the software, we're basically using a viewfinder to find out where we are. So in my office, I have it set up so the 3D Disto is in my office. I'm right here. And I am going to just pick some points along the wall to show you how you capture the data using the software. And then we can go, and I'll show you kind of what's going on with the export and all that kind of stuff as we go through. So I'm going to jump over to the software side of things, and I'm going to just make this big so everybody can see. So when you first start the software, you get a blank screen because no points have been taken, and basically this is, hey, we're ready to go. Over on this side, you have a file drop-down of different features and functions. This is the viewfinder that we were just in, so you can kind of see where you're going. The red Disto button actually captures the point. And then these items down here will light up, when we're using it to orbit and kind of view the model after we've created it. And then on the right side is just a whole bunch of features that are built into the software, like automation for scanning for countertops or automation for doing like a grid scan. And we'll get into that as we go through. So the first thing, and I don't, I want to just show you kind of the basics of the software and just kind of get an idea of how it works. And then I'll show you some scans that we've done just so you can see the capabilities of it. Each scan depends in terms of timing, how long it takes. The more points you take, the more time it takes, which is, pretty logical. And it really depends on each project. Each project we do, I kind of go to the project first and I sit down for about 10, 15 minutes and figure out exactly what I want to export. And then I'll start into the process of actually capturing that data. So right now, with what we have here, I kind of just want to take some points on each of these walls to recreate a quick floor plan of my office. And again, I'm viewing outside of my my door here, so you can kind of, it might look a little odd on the screen, but when you're using it in person, it's where you just follow the laser point. So first point you take, this establishes the 0, 0 point. And you always want to establish that on a straight wall. It'll make your model come out straight and nice instead of at an angle. So I'm just going to pick a point on the wall. When you pick a point, you can literally just pick a point with your mouse. If you can see my mouse here, wherever I pick, the laser goes. I have the ability to zoom in, so I can zoom in if I wanted to find, a specific screw or a nut. And when you're using the tool with a tablet, you have the ability, because it's all Wi-Fi, to walk over to where the laser is and make sure that it's in the correct spot. So you have the ability to zoom in and out. You can change the brightness. I have it set so you'll see previous points, and it kind of like superimposes that over the camera. And then you also have the ability to take a picture. So if I take the first point, so I'm going to just, on this wall, I'm just going to take a point. And I'm going to click the Disto button, and you'll see a number 1 appear in this top screen. And I'm going to go back to the viewfinder, and this doesn't happen each time. If I hit the lock button, it will just stay in the viewfinder. And now I'm going to select another point along this wall. And it doesn't necessarily have to be level. I mean, it depends, like I said, on the project. But there's a nice line of plywood. This was a shop warehouse building before it was my office, so the walls have OSB plywood on them. Gives it a industrial feel in here. So the second point I take is going to establish, so right now you can kind of see a grid has appeared before it was blank. And now when I hit the second point, it's going to align that grid. So when I look at it from the top, that line that we just created is now in line with this grid. Keeps that, and this is the way when we export the drawing, it'll look the same way. The other thing that you'll see too is now that we have a line drawn, there is some measurements starting to appear at the top. So the line that we just drew is 244 3/8 inches. That was on an angle. And then we have a horizontal distance, we have a height change, we have angles, and then these are actually the XYZ coordinates. Seeing that the point number 1 is actually 0, 0, 0. So this point number 2, you can see, has changed in 2 areas, but it's still at the 0. So going back, so now that we've created our 2 points, if we wanted to, if we wanted to remember that this point was in between these 2 wires, we have the ability to take a picture. So I can just hit the picture button, and it'll pop up and say, hey, the picture's been taken. And then when we export this file later, we'll have a view of exactly, it's like a screenshot of this. We'll see the number 2, and so we'll know that, hey, this picture is correlating with that particular point. So I'm just going to work around, again, going back to my floor plan, I'm going to just take a couple points on this wall and a couple points on this wall to start creating the floor plan of my office. You have the ability to take as many points as you want. So I'm just taking 2 points to just establish the wall, but in reality, if I was doing a countertop scan, I might take a point every inch or point every 2 inches. So this really is up to whatever the job is. So I'm going to move the disto over to this wall, and I have some columns set up. So that's kind of what you're seeing in the screen now. And I'm just going to lock the screen so we can go around and just take points. So one of the nice things when you're using this with like a touch screen laptop, you can touch the middle with your finger and move and navigate through, the viewing window very easily. So I'm going to take a second point on this wall, and now we're going to jump back into the drawing view. And you can see kind of, okay, now the drawing is being created. The Z is going to be off just a little bit, but that's okay, because when we look at this in AutoCAD / Microvellum later, we're only going to be looking at it from the top down view. So the first 2 points I took established this wall, and the second 2 points I took established this wall, but then we have this like weird point in the middle. And we can go through and we can edit this. So what's happening in the background when we export this is the points, it creates an actual point in Microvellum, and the line is creating a line. And every time you take a new point, it creates a line between it. But in this instance, we don't necessarily want a line. We actually want to square this corner out. So I can come in, and on the right here, we can delete points, we can delete lines, and then I can use, they have they call it a CAD tool function, where I can select this, and then I can pick, I got to pick the line first. Pick the line first, and now I can do some CAD tools like draw a square, draw a circle around a point, or like extend a line, or do like a fillet of this corner. So I'm going to actually go through and do a fillet of this corner. This is just a little help box that comes up. And what's nice with this is you can turn it on and off. So as you get more experienced with the software, you can just turn this feature off so it's not slowing you down. And now I'm going to just select a point on this wall, and you can see it's creating that corner. So kind of get the idea of going around. I'm going to just do a couple more points on my inside office wall. And I mean, I've done projects where, it's taken a few hours to take points, or done ones that takes about 15 minutes. Really, the sky is the limit when it comes to capturing data, because the amount of data that you can capture is quite immense. The most points I've ever taken with the 3D Disto has been on a project. It was a helical stair project, and we took about 7,000 points. So definitely have that ability. So again, this line here is really not needed, so I'm going to delete it. And then I'll just go into the CAD tools. I forgot to select my line. Go into my CAD tools, and then just fillet that. And what's nice with the Disto is, for the point of this demonstration, it's great. I'm working from one spot, but you can relocate the unit. And when you relocate the unit, it doesn't change the accuracy because of the relocation sequence. And just for time's sake, I'm not going to go through it, but basically what you do is you set the Disto up in one location, and you pick 3 points that you can see, 3 to 5 points that you can see from that location, and then you can move it. So if I had it here, I could pick 3 to 5 points, I could move it over here, hit those same 3 to 5 points, and then I could start capturing data for areas that I can't see, because the tool is a visual tool. So you have to be, whenever I go into a job site, I set it up in a spot that I can capture the most points, just like any laser scanning tool. View is everything. But with this, you have the ability to relocate, which is very handy. And it's great for keeping accuracy. It's a millimeter at 10 meters, and it's 2 millimeters at 30 meters. But if you were to just relocate it in that 10-meter area, you can keep that 1 millimeter for everything. So it's really a great thing. So that was just kind of a basics of getting a floor plan. Now I'll show you just some automated features, and then we'll get into like what the data looks like and how you would export it and play with it there. So I'm going to jump back into the view screen, and I have a wall that has just a few cabinets on it in my office. And it's nice. I have an orange wall and a green wall. So the orange wall kind of like makes the screen go a little nuts. So it's kind of nice having a little delineation between the two. But I'm going to do an automated scan. And this is the feature that you would use if you were doing a countertop template, or if you wanted to kind of just get a cross section of what a wall looked like. And it starts the same way, kind of get the unit or get the view where you want it. And then I'm going to go over to this side menu here. And on the side menu, we have a whole bunch of different tools here, but the automation is right at the top here. And this will you can do either a linear scan or you can do a grid scan. And I'll show you an example of what a grid scan looks like when we're looking at some exports. I'm going to do a linear scan right now. It gives you the option to do a horizontal, a vertical, or a slope. And what's nice with these options, and I'm going to pick horizontal, is after the first point that you pick, the unit itself, when you turn it on, it goes through a leveling sequence. And when you're scanning, everything is level. So what's nice is you can tell if your room isn't level. You can tell all that from the export because the unit itself has a precise leveling mechanism inside. And it's nice too if it gets bumped, if it gets popped or moved, it'll actually warn you and say, hey, the disto has moved, there's a problem, which is nice to not have to run away with errors or have any issues. So when I pick the first point, say this point was 50 inches off the floor and the floor was perfectly level. Every point that it's going to take after this will actually stay on level. So I found this out the first time I used it, and I'm going to just scan to the right. And I'm going to pick. It's asking me what increment I would like to scan at. So I'm going to say for a countertop, I would start at 2 inches in the field part, and then the corners I'll change it to 1/2 inch. So I'm going to click OK. And it's going to start scanning. And I'm not doing anything right now. I could go get a coffee or whatnot. So it's scanning automatically, and you can see at the top it's about every 2 inches, and I'm going to pause it when we get close to the corner here. But each one of these points that it's scanned is on the level, which is great if you're doing countertops. You just set it, I set mine at about 29 and 1/4 for a 30-inch countertop, and I know that it's right where it needs to be all the way around. I'm just checking quick to make sure I don't have any questions. So if I pause for a second, that's what that is. So I'm going to say change the scan interval now because I'm to a corner and I want to have a little bit more density. And I'm going to scan at every 1/2 inch. And again, up at the top here, you'll see now this is changing, and it's plus or minus a little bit for the 1/2 inch. But really, once you see the data, it's everything we need. There's a little piece of quarter round in the corner there, so we'll see that when we go back to the drawing side. And I'm going to pause it now, and I'll just say change scan interval one more time back to 2. And you can change to really whatever you want. There's even a custom one, so if you wanted a strange increment like every 7 inches, you could do that. So we'll just change it back to 2, and we'll let it go just a few more times. And it is still on the level. You'll notice when you round corners, it'll actually correct itself. And I'm going to pause it, and I'll just say skip the rest. And then it has a feature where you can actually edit the scan. So say you were doing a room and you're doing every 2 inches and you missed a corner, you can actually go back and add points into the scan after the fact. I usually fillet these corners in the AutoCAD Microvellum environment, but you can do it in the actual scan environment as well. So I'm going to click OK, and then I'm going to hit this checkbox to say, I'm actually good. And you'll notice down here in this area is our scan that we just did. And it always connects the scan with a line. This is something that you can edit later, or you can edit here. And it says it's part of an auto scan. I just say, okay. So here's our scan. This is a 2-inch. This is where it went 1/2 inch. This is where it went on the quarter round. And now we can bring this in to AutoCAD and clean it up there for a countertop. Or really, when I do a countertop, I just offset about a 1/16, and it works great. What's nice is because the accuracy is at a millimeter, you'll actually pick up mud joints. You'll pick up all of that kind of stuff, and it's great. So there is a question that just came in. Only stage. So the question is from Tyler, and he says, how would you properly measure a room at the stud only stage, or just dry without the drywall? That's a good question. With the tool, what you see is what you get, and so really, when you measure at the stud only stage, it's fine. You can measure those studs, but then you need to properly offset, that 5/8 of an inch or whatever the sheetrock thickness is. And we found, like, if you're doing countertops, with the variations with the mud and the drywall that can happen, it's really best to do it after it's drywalled. I know in some circumstances that's not possible, but as long as your offsets are good from that stud position, and as long as they don't reframe it, it's good. I actually did a closet one time, and I scanned the whole thing, and I came back and I found out that one of the walls, studded walls, was really at a bad angle, not 90 at all. And I let the GC know, and they had to reframe the wall out because it was so off. So it's definitely possible. So, all right, back into this. So this is, it kind of looks a little sparse right now, and it's really because of the time. But you can, orbit this around, and you can use zooms very similar to the AutoCAD Microvellum environment. They have a top view, a southwest view. You can also see perspective if you wanted to see perspective. So this is just kind of how you navigate around. You can draw lines too. So say there was a line that got accidentally deleted. I can just pick a point and draw a line to it, or even add another one. And when I'm all said and done, all that needs to happen for me to export this is to just save the file. And I'm going to just say new folder here. Say demo 1. And we'll click OK. And I'm going to say demo 1 again. So that first one is a folder. The second one is the file. And now to export it, we're just going to go to the file manager, and demo 1 is highlighted, and then we'll just hit the export. And what it does is it exports a couple different files, and I'll show you what they look like. I have 4 screens here, so sometimes I'll put something on and it might go away, and just so you know, data. So this is the export folder, and here's demo 1 that we just did, and it exports the snapshots. So this is the snapshot of that number 1 that I took, or number 2, excuse me. It gives you a little timestamp, and you can see the number 2 on there, which is great. And then you can also see there's a CSV file, a DWG file, DXF for those who might be using another program that can't do DWGs. Text file, and what the text file and the CSV file is it's kind of like coordinates. Basically, it's just a list of XYZ coordinates. I've never really used these, but they are, for people who want to get into it a little bit more, there are there. And then there's actually a PNG file, and this is the same picture that we took. And what's cool is when we open this up in CAD, it actually adds those pictures right to the DWG file, so you can see them as like a X reference. And then there's a 3D CAD and a 2D CAD. And the difference between these is the 2D CAD has been flattened. So like if you're doing a countertop and you want to just have a flat view of it, and you don't want any Z values, this will be a flattened of the top-down view. And then the 3D file is going to give you, and these are both DXFs, this will give you the 3D look, same as the DWG file. So I'm going to go, I see there's another question. I'm going to see what it is. Is there a pipe? Oh, okay. So David said, is there a pipe or a heater in your office, and how you would address those? I kind of understand the question. So basically, with anything like that, I'm trying to think if I have a pipe. I have some. With anything like that, I would probably use, like if it was a pipe and it had like a 4-inch diameter, I'd probably use an auto scan and just try and do a cut through it just to see, you know, if the diameter is correct. Just for time's sake, maybe we can talk about this after, but that's a good question. I'll show you, I think some of my examples too of the exports, you might see some items that we worked around when we had more time. So this, I'm going to go back and just show you just a couple more in-depth files that we had more time to work on. So this was a countertop template, and we're going to be playing with this in the Microvellum environment. But what I did was I set the Disto up on a tripod, and you can see it's kind of like off the ground there from this view. And we're putting a countertop in this whole area. It's a 3-sided countertop. And I just set it on auto scan and let it go to town here. I think I did 2 inches. Yeah, it was 2 inches on the straight part and every inch in the corners. And you can actually see here, it picked up the mud. You know, see how it comes in just a little bit. And even over here, it picked up the mud. And like this area where it's a little funky angle, if you just do that fillet command, either in this software or in an AutoCAD, it kind of cleans it up. So this scan took me about 20 minutes between setup and takedown. Very quickly able to capture countertops. It's a great, phenomenal tool for that. Oops. Next scan I'm going to show you with just a little bit more in depth. I have a list of ones. So this one, I had a customer, and this one looks just a little crazy until I start orbiting it. So I had a customer who had done wall paneling in a particular room years before, and their client wanted him to come back and actually match the ceiling paneling to the wall paneling. So what I did was I captured the perimeter. So I kind of have the perimeter, and there's some parts in here that, you know, where I did an auto scan, and I, for time's sake, at the job, I didn't clean it up, and I went back and cleaned it up in AutoCAD later or Microvellum later. But I captured the perimeter, and then these squares were speakers that were in the ceiling. All the circles were lights that were in the ceiling. And then I did a grid scan, and you can see kind of the points that are just floating in space. In AutoCAD, it puts faint lines in between. But these grids were a grid scan. So I just took a grid scan to see if the ceiling was out of level. So we could account for that in the paneling that was happening there. And then if you'll notice, around the perimeter, just a little bit lower, about 12 inches lower than the ceiling, there's a whole bunch of points. And these points were the seams of the paneling that he had previously done that we had to match up with. So I was able to set up the Disto in one location and basically capture this data and then bring it back into the Microvellum AutoCAD environment to then incorporate all this information into the drawings that were created. I'm going to just look and see. So yeah, Owen asked if I identified the speaker and light locations using the laser. Yes, I did. Because the laser has the ability to zoom, I was able to pick the corner and the ceiling was about 13 feet high, and I zoomed in, and then I was able to make sure I was in that pinpointed spot for the corners of the speakers, and as long as the laser is right where it needs to be, you can go from it because it's a millimeter accuracy. I'm going to go back to, oops. That code 2 is just a camera error. I'm going too fast. So this was another example, and I'm going to show you one more, and then we'll get into like kind of what the export looks like and how we work with it.
Hey, Adam.
Yes.
There's another question that came in from the chat too.
Okay.
Jose, he's asking, I understand the laser has the ability to project the DWG geometry directly at the job site. How is this done?
That's a very good question. And basically, if I go back to my folder here, we have in the Disto folder that it creates when the software is stuck in there, there's an export folder, import folder, license, blah, blah, blah. So the export's where all the exports happen, obviously. The import is what you would do if you wanted to project. The thing with projection, though, is you have to project a single wall at a time, and it's a little involved. But when you're doing it properly, it's phenomenal. The accuracy that you can achieve with this. So basically, what you would do is you would maybe I can go back and show. So say we were projecting these points onto the ceiling. Say I took this drawing and I flattened it, and I needed to add a couple other speaker locations, and I wanted them to be evenly spaced with the ones that were currently there. What I would do is I would flatten this drawing in AutoCAD, and then I would add the points and the lines that I wanted to create those additional speaker locations, and then I would stick that file. I would say that file has a different name or whatnot, and I put that in the import folder, and then I would go back to the site and I would pick points of reference. So like maybe pick some points on the sides so that I could orient this view so that I would, basically so that the projection would be overlaid in the room properly. And then I would be able to just pick a point, and instead of, in the projection feature, instead of using this to take the measurement, you actually use this, and it moves the laser to that point, and then it blinks until you've done with that point, and then you can move to another point and move to another point, and then you can project these points or the spacing on that. So that's, yes, that's available, and more than happy to talk to anybody after about that. So that's a great feature. I'm going to just show one more room, and then I'm going to get into the AutoCAD side of things because we're getting close to that time. So last one, this was a project that I had that was a little bit more crucial, that I had to match, and this was before I was understanding the first 2 points established. You can see everything's kind of at an angle. This is an easy fix in AutoCAD, but it looks cleaner when it's straight on. So this was a church door, and we couldn't rip out the door before the new one was made, which I'm sure some of you guys have had that experience. So I had to go and I had to scan this, and I had to basically capture all of these ornamental areas and then bring this back in and create the door drawings from it. The one thing about this project, though, that you can't see from this file was it was about -10 degrees in New York City when I was there, and I was able to place the unit on the outside of the door, and because it's Wi-Fi, I was able to work on the inside of the door where it was heated and capture all my measurements. So there's some benefits to using the unit that way that are very very cool. So that's really the software side of things. Obviously, there's more that I could go over, but I really want to show you kind of what happens after the fact and show you a little bit of how to integrate it with the Microvellum side, and really how to process the data. Like I was saying before, with those point clouds that capture millions of points, it really is a great tool, but you have these millions of points now that you have to process. So with the 3D Disto, we can accomplish similar things, but in terms of knowing how the room is oriented and angles, but then the points, depending on how you take it, the points can be processed a lot faster. I think there's one question that might have come in. Robert, sorry, I'm reading a question here. Robert said, did any of the tools help with the door? Did you need to use the viewfinder and manually add points? I think he's asking, did I do automation with the points for the door? So I did automation on certain areas, and then there was some areas that I had to pick them manually. But I was probably there for about an hour and a half to capture that data because I had to move the unit a couple of times. So, the time it took to do the manual points was pretty minimal when it came to the overall scope of that project. So now I'm in the Microvellum world, and I am just going to kind of show some of the how to take some of the data that we've captured and bring it into a useful situation in Microvellum. And the first one that I have is that countertop that we were looking at before. So when I had that data and I exported it, I opened up the DWG file, and this is what it gave me. This is just so you can see, and I mirrored this so the numbers are a little backwards, but that's okay. It gives you a point wherever the laser point is, and then in between those points for this automated scan, it drew a line. There's a way to turn that feature off, but for the most part, it's very useful to have that line to know exactly where these points are. And then the thing that happens, when you're looking at it in the CAD environment, is you also see it assigns a point value to each one, or not a value, but just an identifier. So this scan was about 188 points. I started over here and I kind of just worked my way around, and this was the data. So what I did was I took the data out and I opened up the 2D file so I didn't have to bother flattening it. And then I created a polyline. I just joined all the points together and I created a polyline for the wall. And if you'll notice, on this part where the countertop isn't, I just use a straight line. And then on all the parts where the countertop was touching, I left the scan exactly the way it came off of the unit, other than filleting these to make them square or corners. It was exactly the way it came off the unit. And then I took that and I basically offset just a 1/16 of an inch, because if you're tight, the countertop won't fit. And we've had that problem too. Lewis is asking, how long did it take to scan all these points? This was an automated scan. It took about 20 minutes, maybe 25. So it was very, very quick considering the customer that I was doing this project for. I think the countertop material was like $800 to $900 a sheet. So he said, he wanted to make sure it was spot on and they didn't have any issues or errors, and we were able to do that. So I took the drawings that I received from them and I just kind of created the countertops in here. And now I've isolated the countertops, and you can see the front is a nice straight, crisp, clean line, and the back is scribed. And then I just took those and I've oriented them into sheets. And then in the Microvellum side of things, this was just my worksheet. And all I need to do now, so I'm just going to copy this. So I created a project for this particular demo. And just to kind of give you an idea what this project looks like, here's our project, here's our live event. I have a countertop that I want to show you. I have a creating walls from the scan, which is really a cool thing. And then I have doing a die wall. So like if we had a soffit that we had to match, we can do a die wall and match it. So I'm going to show you each one of those. And right now I'm in the countertop area. So what I did was I just created a nest sheet. I opened up a blank drawing. I didn't really need to go through, and I could have added this as a product, but I just wanted to create a nest sheet. And I used that with the 2D machining tools. And I selected the material. So right now I'm just doing it out of plywood, just for sake of showing. And I'm just going to hit draw. So I picked a 4-foot by 10-foot sheet. And it's asking me where to place it. And I'm going to say 20 inches from there. So here's my 2 sheets. And now I'm going to drop in the counter. So there's the first sheet. Here's the second sheet. And these are closed polylines. And now I'm going to use the 2D machining again and go to routers. I have a 1/2-inch router. I'd like to make it 3/4 deep. And I'm just going to pick the entity points. So I'm going to pick that one. And now it's created a router. This one looks like it did the wrong way. So I can just say, hey, go right instead. That's an easy fix. I like how, I used to do this quite a lot when I was doing the CNC part of things. And this feature is just a great feature. And this one's off, and I would just do that same thing. Just switch left to right, and we'll try this one. And this is, once this is done, you process the work order, it creates a G-code, you cut the counters, and you're done, and it's scribed and it's ready to go. So the scan took me about 15-20 minutes. I just saved the guy who's scribing this countertop in. I just saved him probably two or more hours of work scribing it in. So that's where, the scan time versus measuring time might be pretty comparable, but when you start factoring in how much labor it saves, you can see the benefits, especially using Microvellum software. Because, if you don't have a CNC, scanning is like, okay, it's nice to be able to understand what the walls are doing. But like for instances like this, you have the Microvellum capabilities to just add that right in. You're using a DWG, so Microvellum can read it. This is why I think it's a great thing. So then the next scenario I want to show is a wall paneling scenario. Now this was a project that I did where, and I'll show you, I kind of edited the scan a little bit. So here's like the 3-dimension of what this looks like. And all I did was, these are still the points and the lines that were created in the Leica file. And all I did was I went through and just changed the color. So all the floor lines, so all these lines are where I snapped on the floor, are magenta color. The bottom of the walls I made red. The ceiling I made green, and so on and so forth, so I could isolate each area. I have windows in here. I have all that kind of stuff. And then I took all that information and I processed it through. So here's my start. And then I kind of went through and I added some lines to it. Because really, in our world, we don't want to make our panels, or we don't want to make our millwork at a funky angle or at a skewed angle. We want to compensate for what's happening in real life. So this tool allows you to scan what's happening in real life, and Microvellum allows you to compensate for it and figure out, okay, what do I need to do? What are my constraints to build my cabinet square and nice, but still make it look nice when you're done. So what I've done is this is my picture of the real world, if you will, in scan. And then this is the picture of, the paneling that's going over top. And I overlaid it over the real world, and now I kind of built to the constraints. So I fit to the corner, and I can come over here and see how off the wall is. And because I changed the colors, I can tell that this wall is out of plumb about 1/8 of an inch. So you can see it down here, this distance. And I went around and, you could tell some areas were a little bit more off than others. And to build this square, we actually had to be off the wall a little bit. So we padded out. And what was nice is I actually got together with the cabinet maker who was installing this, and I did a view screen just like we're doing right now. And I went through each area of the room and I said, hey, this room, this is off this much, this is off that much. So instead of him getting there to the job site and trying to figure all this out on his own, he was able to just take my notes from our meeting and go to the job site and say, okay, I need to make my French cleat this much thicker, or I need to add this much blocking to it. And what I did in the Microvellum side of things is, because we're going to build everything to that nice number, I've worked through and I've come up with these two floor plans. So this is like the one that doesn't have the windows trimmed out, and this is the one that does have the windows and doors trimmed out. So I created this floor plan, and this is what, all the paneling is going to be built to, and then the padding is going to happen in the back. And I created another file, or I just created a room in Microvellum. And if we wanted to take that floor plan that I created from the scan data, so we know this is right and true, and we wanted to, put our paneling in there and see how it's all going to line up and see how everything's going to work, we can just drop this in here and we can draw a wall. But instead of drawing a wall to, the points that you pick, you can actually pick a polyline. So I'm going to pick a polyline and I'm going to select this. This is going to take just a second, but you'll see it kind of working. So now what Microvellum is doing is it's actually just going through and creating walls ready to go for products that we want to add. If I was doing millwork in this room, we'd have everything accounted for. And what it's doing here is, I didn't actually put in arcs there. This was elliptical, so it was a little funky, this entryway. So put in a lot of little walls, but there's really no millwork happening there. So it's not really a big deal. But it's great to be able to, come up with this polyline and then just drop it into Microvellum and have it start drawing the walls, and it's smart that way. And so here we have, our view. And if I change this to maybe this conceptual, we can orbit this around, and now we're starting to recreate the room that was scanned in that perfect where we know all the millwork is going to fit now because we've already gone through and figured out. So that's an example of just kind of taking walls into effect. And then the last thing I want to do, and before we wrap it up because we're getting close to the top of the hour, is just kind of go over a soffit. So this was a scan that I took where I wanted to just get the curve of this wall. And I created the curve, or I scanned the curve, and that's this data here. And you can see I have, a point every 2 inches. And I copied it down, and then I superimposed some arcs over top. So when I did a full arc, the wall wasn't actually perfect, so this came out just a little bit. So I superimposed a true arc over top of it, and now I want to take this data and I want to create a die wall that's going to match this soffit below. And I'm going to use that using Microvellum's solid modeling tools. And I have it here. I did see a question come up. I want to take a look at that. Okay, so Lewis asked me, will it allow you to see the floor or ceiling that is off height-wise? Does the floor automatically snap to the Z-plane and generate? Yeah, that's a great question. Let me just jump back into this file, and I can show you kind of how you would figure that out. There's a couple of different things that you can do. But when this drawing is created, when you export it, you can see there's like a little XYZ here. The first 2 points that you took were, remember that 0, 0. So if I did an ID in this in AutoCAD, you'll see we're 0, 0, 0. What you can do though is it's accounted for level. So now I can actually go through and I can pick ID points anywhere on the floor or the ceiling, and it'll tell me, the differences in Z. So I can see, okay, in Z, I'm negative 71, negative 71.53, negative 71. So this floor from the points that I just selected is a variation of about a quarter of an inch. So this is how I use that to figure out how off the floor is and the ceiling is. You can also use a list command, but you can also go in and like see from a side view. I can put in a line, and this line can be similar to a benchmark if have ever used one of those when you're measuring with standard tools. So once I've created this benchmark, I can now measure, I can take this view and either flatten it and then start adding measurements to see how off the height of the floor and the ceiling is. And it's very good. I mean, you're just basically, again, you're like taking a picture of the real world and you're bringing it into a Microvellum AutoCAD environment, and you can finish taking measurements back at the office instead of having to mess with it in the field. So back to my die wall. So this is the soffit that I want to match. And what I'm going to do is, because I want the die wall to be perfect, I don't really want to have an extra couple of arcs in there, which I have for the actual soffit itself. I'm just going to superimpose a true arch over that. And this is what I would do. I'm not doing this for the software's sake, for it to be an easy fix for the software to not have any issues. I'm actually doing this, if I was building this, I would want it to be a true thing and not have those little jogs in it. And honestly, with the soffit being 8 feet in the air, you're never going to notice this anyway. So I'm going to just, and if you needed to, you can do it. It's definitely possible. So I'm going to just throw the original soffit back 50 inches. And now I have this line here. And it's as simple as using the solid modeling tools. So if you go over to the solid modeling tools, select the tools. I already have it open, so it just yelled at me. And now I just right click and add, and I'm going to add a extruded product starter. I'm going to pick this as the construction path, and I'm going to go back to the right one, and I'm going to say, hey, I want to pick points, or I want to pick items that I want to extrude. So if this is the reception desk that's happening there, I did this on purpose so that I really did do this on purpose. I'm not blowing smoke. So that you could see, if it comes in the wrong way, that's really no big deal. You can right click and you can reverse, and it'll redraw it the other way, which is the way I was intending to see it. And now we've just matched, this die wall very quickly using both Microvellum and the Leica tool to the soffits. And I kind of have a pre-done one here. So, this is the soffit above. Here's our Microvellum die wall, and we can orbit this, and you can see that, that's pretty easy, pretty easy to take it from the scan to this. So I pretty much at that time, and hopefully this was informative. I just making sure I'm checking my notes here. That's pretty much it. I have I've used this tool and the software for years, and I think they work very well together, and it's one of those things that really makes life very easy. I'm just looking, there's some other questions that are coming in. You can also. So we have a question from James, and it says, can live drawings be done in the field with AutoCAD, meaning you can draw in real time if the Disto is connected to the laptop with CAD on it? There's an add-on software that you can get to do that. where it draws real time in like AutoCAD or even, but honestly, in my workflow, I haven't found too much of a need for that. It could be a need for you, but because, the Leica software is showing you really everything that you're going to see in CAD, and it's very simple, you can take this and export it and open it up in CAD and mess with stuff very quickly. I found that works really well when you're in the field. So I'm seeing, I think there's some other questions coming in here. Oh, Jose asks if the solid model extrusion has machining side. So what the solid model extrusion has done is it's created this, let me actually change the visual to a wireframe here. So you can see it's created, all the studs, and it's created everything here. And when I'm done and I'm happy, like we've created this, this 3D model, and it's exactly what I want, you come up here and you just basically right click and you hit save, and it saves the product, and then it goes through and it creates all the machining, and it creates everything that you've drawn in, and then you're able to treat it just like any other product in Microvellum. You can go through and nest it. You can add more machining to it if you want to. It's not a parametric product, so the suggestion is you get everything set, you make sure it's all approved, and then once it's approved, you say, okay, let's make this a product. But it works great. Yeah, so I'm just checking to see if there's any other questions. Hopefully this has been informative. We did another webinar before, and we had a lot of questions about this, so I think hopefully this has been a good thing for everybody.
Yeah, I think it definitely has, Adam. Yeah, we did do one of these a couple months ago, and it was kind of the reverse of this. We spend a lot of time in Microvellum showing how you can, use some of the drafting tools and kind of what you're showing now. And a lot of people wanted to hear the reverse of it. They wanted more information about the 3D Disto, and then so I think today's information you presented was great and right on spot. And I did want to make a comment there too. There was a question that came in regarding the machining there and if it was added automatically and how that works. And we had a presentation, live event a couple weeks ago that showcased the solid modeling tools. And yes, so the machining, it's handled a couple different ways. And so there in the section view that you see on the screen, there's you see all those different colors, and those colors are actually what we call are assigned to smart layers. And so those are layers that are a little bit different than AutoCAD layers, to where we actually assign different properties to them. So for example, if you looked at a stud or even a plate, there's information in there that you can set up to either show the machining or even calculate how that machining is applied. So in that stud property, you'll find options for, the spacing, how far you want those studs to be to be distanced, this distance between those studs, whether or not you want them dadoed or doweled, different things like that. And then when you grow this, and as Adam mentioned, once you save this back to the Microvellum product library, it's not really parametric, but in this environment, when you're working it with the solid modeling tools, you can drag and stretch and grow and append and add vertices to those construction paths to basically transform that into whatever you need to, while all the while looking at those automated settings and layer properties. So just wanted to comment on that real fast.
Yeah, and it's a really, when I was using Microvellum more in the manufacturing side of things, we didn't have this ability. So we would have to go through and we'd have to do all these 3D drawings. And, I did a die wall once where I had it perfectly parametric. It was great. And it took me about 40 hours to create. And now looking back at that project in 6.7 that I did, to the tools that we have available now in the newest version of Microvellum, I could have done that same project in probably 10 hours or even 8 hours. And it was pretty complicated desk. So these tools are highly, make things highly efficient. And it's just great to be able to take it, from this environment and bring it right into Microvellum. And honestly, the parametricness, because of the ease of going back and forth, like, you could just draw another one and do it. You don't the parametric is nice, but with these tools, it gives you the ability to just customize things so much faster.
Right. All right. Well, I think, yeah, it was a good event today and lots of good questions that came in. That was great to see that. And thank you definitely, Adam, for taking the time to join us on this live event today.
Definitely my pleasure.
Yeah, so yeah, I really liked the presentation today, and I can definitely see after really watching this demo in depth on how, not using a tool like this, if you're trying to build millwork or cabinetry around imperfections within, whatever the framers left you behind, can definitely be frustrating if you don't get that exact information figured out ahead of time.
Yeah, definitely.
All right, so if you want to learn more about this tool and others that are available from Advanced Dimensions, you can visit Adam's website at advanceddimensions.com. And so you can learn more about the laser systems there on his website. All right, so that will about wrap it up for today. I just have a few other things to talk about in conclusion for this. So let me get things transferred over. All right. Well, if you tuned in last week, we announced our online training courses that we are preparing to launch, and I'm happy to report today that as of this morning, registration is open, so you can go to our website to learn more about our online campus events that will begin in January. So remember, these are initial courses right now that will be offered to deal with some of the fundamentals of Microvellum, getting started with the drafting, like we talked about last week, as well as moving into some custom product creation using the product starters that are available in the library, as well as in the solid modeling tools that we ended this webinar off today with. So definitely check out our website where you can learn more about those events. And if you are in the Los Angeles area next week, you may want to stop in and see us there at the Laguna Lockdown and Microvellum Open House. This event starts at 9 a.m. on Thursday of next week, and you can learn more about this event as well on our website. And finally, next week, we will also be hosting another live event, as usual, on our Wednesday at 11 o'clock a.m. And this week, or that week, on December 13th, we are going to be having our live stream, our Q&A live stream event. And so these are fast-paced events where we have questions presented by our teams, answers presented that are collected throughout the last month or so, and we present those questions or those answers for you live. And we're also going to be taking your questions live as well and getting those answered. So we're looking forward to this event coming up next Wednesday at 11 o'clock a.m. Pacific time. So I would like to thank you for joining us today. Thanks again to Adam, and I definitely hope you have a great rest of your week, and we will see you on our next Microvellum live event.